All right, so we've got another one. We've got 3 logs this time, but only 2 of them have x's. So, and they're all natural logs, so they all have the same base. So here, my strategy is probably, if I could get the x's into 1 by themselves, then I could use my log base equality property. But this one, there's several ways you could solve it. They should, if you do them correctly, all come out the same answer, and we can double check by graphing. All right, so this one, we're going to start by saying, hey, I can use my quotient property to rewrite the left-hand side. We're going to have ln x over x minus 4 equal to x ln of 3. And at this point, we can say, hey, the log base equality property, log, I'm just going to call it equality property, because if these two things are equal, then the arguments, x over x minus 4, has to be equal to 3. And we can solve that one pretty quickly by cross multiplying and distributing and moving x's to one side and constants to the other, and we're going to get x equals 6. And we're going to graph this to make sure. All right? So let's make this smaller, move to here. All right, so we're going to have y equals ln of x minus ln of x minus 4, and y equals ln of 3. And we're going to say, okay, where do these guys intersect? Got 1, 2, there we go, E, right at 6, which is what we had gotten for our answer. So these are nice because you can self-check, and hopefully that these will point you, if you do make a mistake, they'll point you, help you figure out where you did your mistake. All right, so we've got one more of these, and they just keep looking more complicated. So this one, you can combine all of them into one log. That's going to get pretty unwieldy. But what we can do, since all of these are the same base, we can basically do what we did in the first one. We're going to use our log product rule to combine on each side. So we have log of x times x plus 1 is equal to log, let's see, I forgot the base 3, of 2 times x plus 3. All right. And now we can say, hey, now that we've rewritten these, we're going to say, hey, I can use my log equality rule to set the arguments equal to each other. Okay. So we're going to say, okay, if these two logs are equal, then that means their arguments got to have to be equal. So x times x plus 1 has got to equal 2 times x plus 3. And this is going to just be a quadratic, right? So I'm going to distribute, and I'm going to solve. I'm going to get everything all on one side. X squared minus 2x, so that'll be minus x, minus 6 equals 0. And so I've got x minus 3, x plus 2. I feel like we've been here before. So x is equal to 3 or negative 2. Now, one of these is not going to be allowed, right? Because we can't have negatives in the argument of the log. Now, if the whole argument together ended up being positive, it would be okay. Like this one, we can plug negative 2 into log of x plus 3. That would be log of 1, which would be 0, right? But we can't plug negative 2 into log of x. So this one is not in the domain of all the logs, so we have to throw it out. And our only answer is x equals 3. All right, and our last problem here is looking a little intimidating, but kind of like the last one that we had in 6.5, our first thing to do is to simplify, okay? So we're going to simplify first. Okay, so we're going to deal with these in pieces. So we've got e to the x divided by 1 over e to the x, right? So, because that's what e to the negative x is. So we're looking at the denominator first because that's a little simpler. And remember, when you divide by a fraction, it is the same as multiplying by the reciprocal. So we're going to be e to the x times e to the x, which is e to the 2x, right? E to the x plus x. Okay, so we've got the bottom simplified. Now the top, we're going to say, okay, great. I've got square root. Let's see. We're going to distribute, because this is a product, so we can say e to the 2x to the negative 4. So that would be e to the negative 8x. And e to the negative 5x to the negative 4 would be 20x, because when you raise a power to a power, you multiply, right? Okay. We've got e to the 2x here. Okay. Now, here, we can deal with the e to the negative 8x times e to the 20x using our product rule. So we're going to add our powers. So we've got square root of e to the 12x all over e to the 2x. And then we're going to finally get rid of that square root. You could have done this earlier. It's fine. We've got e to the 12x to the 1/2, which will be e to the 6x then. And then we're going to simplify that. Remember, when you've got a quotient with exponents, you subtract. So 6x minus 2x is 4x. So we've got the left-hand side down to e to the 4x. So we've got e to the 4x equals e to the 7. And then we've got our exponent equality rule, right? That first thing that we talked about, 4x is equal to 7. So x is equal to 7/4. And we're done.